Alright guys, welcome back to Underground Science, and in this video we're going to be going over an example with the mechanism of an acid catalyzed hydration reaction. Okay, and so remember, hydration is the addition of water across a double bond. In this case a double bond because that's what we're talking about in this video. And we've been talking about hydration in the previous videos, and so let's go in and jump right into example. So the first example we're going to go over right in this video will be like a hydration reaction that we're doing in previous videos, but there's going to be one extra step we have to watch out for. Okay, so if we add acid to this, and then let's see what happens right after we add acid. So if we draw the mechanism, we have this molecule as a reactant, and then if we draw all the bonds out for hydronium, which is our acid catalyst, we're going to have something like that. And then from our previous videos, we know that the alkene is going to be the nucleophile, and the hydronium will be the electrophile. So we're going to attack the hydrogen, these electrons are going to go on the oxygen, then we're going to have something like this. Then we're going to have water too, right? Because hydronium lost the hydrogen, so now we're going to have water. And next, what we would think happens is that this water, right, will attack the carbocation, right? That's the most logical step, next step. But remember, this is a secondary carbocation. You have to look next door. So what's next door to this secondary carbocation? We have two carbons, right? This is a primary carbocation, and the person next door, though, he's a tertiary carbocation. So what if I took this imaginary hydrogen, right? Because we don't draw the hydrogens in a line diagram, right? But in this case, let's draw it out so we can see. What if we took this hydrogen and put it over here on this carbon? So that would look something like this now. We would have this hydrogen here, right, moved from here to here, and now we would have the positive charge here. So let's compare. So now if we write this out, let's compare. This positive charge is now tertiary, while the positive charge here was secondary. Who's better, a tertiary carbocation or a secondary carbocation? Right? The answer is a tertiary carbocation. So this is going to be the intermediate we're actually focusing on, and this will be the intermediate in which this water molecule will attack. So now the pair of electrons on this oxygen, right, since oxygen is electronegative, and for also what you have to focus on is we have an electron pore area here, so it's pretty clear that this is going to be electrophile and water will be the nucleophile. So the lone pair of electrons on oxygen will attack here on the carbocation, right? And that will lead to a bond being formed between carbon and oxygen. So it looks something like this. Right? And this is our bond that the oxygen made to this carbon. Okay, so let's draw this on the next page and see what happens next. Alright, so this is what we have so far. Next, what's going to happen, right? So let's make a quick sidestep here. Remember our reagent, we reacted the reactant with hydronium, right? Because this is acid catalyzed hydration. But how did we get hydronium? We reacted a bunch of water molecules with sulfuric acid molecules, and then we got hydronium, right? And then of course we got the conjugate base of sulfuric acid. But that's not important right now. What we're focusing on is the hydronium. How did we get the hydronium? Because we reacted a bunch of water molecules with sulfuric acid. So we have the option of taking a water molecule. Because we have so many of it, we can just take a water molecule and react it again in this step. So what's going to happen is this water molecule is going to come in and take away a hydrogen, because we have to get rid of this positive charge, right? And those electrons will go on the oxygen. So our product, our end product, will look something like this. We'll have an OH here, and then we'll have our H there and an H there. And this will be our final product. So let's go and write that out in this diagram right here. So it's going to look something like this. Have the OH there and the H the two H's here. Now we don't have to write the H's out, but I mean, this H was part of the hydride shift, and this H was part of the first step of the reaction mechanism, in which we got the H from the hydronium, right? So that H is this H. And again, this shift that we showed here, right, this carbocation rearrangement in which we went from a secondary carbocation to a tertiary carbocation due to this shift of the hydrogen, this shift is called a hydride shift, okay? And we've went over this in one of our previous videos. All right, so that's basically it for this video. And in the next video, we're going to go over another example of acid catalyzed hydration, but it's going to involve a methyl shift. All right, so I hope to see you guys there.